blue. Because, I don't know, I'm just lazy.
Hey, you guys want to see some magic?
No thank you.
Come on guys, it's magic.
Oh, why are you touching me?
Man, those guys are weird, huh?
Yeah, they're pretty creepy.
You guys want to see some magic?
Who are you guys?
I'm gay. I'm Indian.
Well, what the hell can you guys do?
Come with me.
Ah! The bling reflected in my eyes!
Speaking of reflection,
Oh my god, you okay? No!
I think it's time to leave. Indian power, gay pride.
Reflection of light and sound. Reflection is the bouncing back of a particle or wave that strikes the boundary between two objects. There are two types of reflection, specular and diffuse reflection. This concept applies to both sound and light. The law of specular reflection. Specular reflection has two characteristics. The incident ray, the reflected ray, and a normal line to the reflection surface at the point of the incidence lie in the same plane. The angle which the incident ray makes with the normal line is equal to the angle which the reflected ray makes the same normal line. The law of reflection for specular reflection is basically the angle of incidence is equal to the angle of reflection. We see an example of specular reflection, in which a flashlight is being shown into a reflecting surface, and that it's being reflected directly into an eye. We can see that the angle of incidence is equal to the angle of reflection, and that the normal line is perpendicular to the reflecting surface.
Gay.
A diffuse reflection. A diffuse reflection is a reflection of light from an uneven or granular surface, such that an incident ray is seemingly reflected at a number of angles. Characteristics of diffuse reflection. Light is reflected at different angles, and will appear not to produce a clear reflection. You can see here a diffuse reflection, in which light rays are shining on a surface which is not shiny or smooth. You can see that all the reflected rays are scattered in all directions, and thus not form a clear image. The reflection of sound is also used in sonar, or sound navigation and ranging. As we see here, a sender-receiver unit is sending a sound wave that travels a distance away to an object. The object then bounces back that sound wave back to the receiver, in which the receiver can calculate the distance between the two objects.
Hey, when did you get this? Pick the card. Pick any card. Really? Oh, look at the card. Show it to the camera. Okay, now take that card and put it in your pocket. Okay. Indian. Take out the glass cup. See this cup? It's empty, right? Don't believe me. Check yourself. It's empty. Is it empty? Yeah, it's empty. Okay, now watch this.
Never's all paranoid about it.
Dude,
Now look.
what the F? Dude, whoa, what the F?
Dude, how'd I get in there, dude?
Dude, how'd you do? Are you like David Blaine? Dude, whoa, man. Dude.
Refraction of light and sound. Refraction is the change direction of a wave due to a change in its speed. This is most commonly seen when a wave passes from one medium to another. Light will not travel in a straight line to different mediums because different mediums will cause light to bend. Snell's law. It is a formula used to express a relationship between the angles of incidence and refraction when talking about light or other waves passing through a boundary between two different media, such as water and glass. The law says that the ratio of the signs of the angles of incidence and refraction is a constant that depends on the type of media. Here is a visual example of Snell's law, where theta 1 and theta 2 are the angles of incidence and reflection in the normal line.
Hey, want to see a rainbow?
Okay.
Watch. See the rainbow? Can you taste the rainbow?
What the F?
Prisms is a transparent optical element with flat polished surfaces that refract light. A prism can be used to break up light into its component spectral colors, the colors of the rainbow or visible light. Prisms can also be used to reflect light or to split light into components with different polarizations. Dispersion of light in prisms. Upon passage through the prism, the white light is separated into its component colors: red, orange, yellow, blue, and violet. The separation of visible light into its different colors is known as dispersion. We commonly refer to the visual colors of the dispersion of light, Roy G. Bibb. The visible spectrum is a spectrum that the human eye can see. The visible spectrum of light. As we can see here, the higher the frequency across the spectrum, the shorter the wavelength of that spectrum is. That is true for vice versa. For example, red has the lowest frequency, but the longest wavelength. Critical angle and total internal reflection. The critical angle is at the angle of incidence where the maximum refraction occurs. When a critical angle for two substances is exceeded, a phenomenon known as total internal reflection, or TIR, occurs. This means that instead of exiting the optically dense material and being reflected, the incident ray is reflected inside the material. Total internal reflection. As we see here in an example, a laser beam is shown into an aquarium, where it is reflected off the surface of the water and being reflected back down into the tank. There should be a critical angle, whereas the angle with the surface gets smaller, all the light will be reflected from the water surface back into the aquarium, and none will be refracted out into the air.
No! No!
Come on, Jazz!
Just give us some of the bloopers, it's funny.
I'm Indian.
Keep going.
I'm Indian. I'm Indian. I'm Indian. I'm Indian. I'm Indian.
Yeah, that was perfect.
I'm Indian.
Wait, move back a bit.
I'm Indian.
Move back a bit.
I'm Indian.
Do that thing. With
I'm Indian. I'm Indian. I'm Indian.
Do the thing with the chain, dude. I like. All right, go ahead.
No, okay, no. Okay. I'm gay.
All right. Ready, set, go.
Man, this doesn't weird.
Damn it!
Oh, wait.
Go.
Yeah, it is.
Ah! Oh no, I forgot.
Keep doing it. Keep going. Keep going.